Welcome to Linear Programming Basics 3 tutorial. In this tutorial we will learn how to interpret output. In particular, we will look at the answer report. In Linear Programming Basics 4 we will then finally look at how to interpret the sensitivity reports. We will continue working on exercise 7.3 from the Data, Models and Decisions textbook. Previously, we had solved this problem graphically after we had formulated it. Then we had input this problem into Excel. Now we will interpret the output from Excel. Recall that this problem concerned an artist who was manufacturing small and large vases. The artist wanted to maximize profit, subject to time constraints, to material constraints, and to storage constraints. As a consequence, we had the following linear program. 10s plus 12l was the objective function to be maximized, subject to the constraint 20s plus 20l less than or equal to 2400, 10s plus 20l less than or equal to 1600, and 2s plus 3l less than or equal to 260. In addition, we had the non-negativity constraints, of course, since we cannot produce negative amounts of vases. We solved this problem previously in two ways. One was the graphic way, and the other one by putting it into Excel and looking at the answer report. So let's have a look in more detail in what the answering report tells us. First, let's look at the final values for the adjustable cells. Recall that the adjustable cells concern the variables. The first variable, the variable for small vases S, has a final value of 100, and the second variable, the variable for large vases L, has a final variable of 20. This we had previously seen in the graphic solution. We don't have to concern ourselves too much with the original values here. The original values is simply what we had initially in our solution when we started Excel. Usually we do not care very much about these values. However, sometimes we want to understand how much did we improve from a specific solution that we perhaps knew already was feasible, or our status quo manufacturing. So sometimes this is interesting, sometimes, or usually, however, it is not. Next, let's look at the objective function value, or the final value that the objective function assumes. Notice that the objective function reads maximize 10s plus 12l. Well, putting in our final values 120 into the objective function turns the objective function into 10 times 100 plus 12 times 20, and that is equal to 1240, our final value of the objective function value. Next, let's look at the row for the artist equations. Let's look at cell value 2400. What does that mean? Recall that the artist equation read 20s plus 20l less than or equal to 2400. Now, with our final values for the variables, 10 and 20 respectively, this reads 20s plus 20l equals 20 times 100 plus 20 times 20 equals 2400. This constraint is binding and it has a slack of 0. Why is it binding? Well, the left-hand side 2400, which is the value for our equation is exactly equal to the right-hand side, 2400, which is the number of minutes we had available. So the artist uses up exactly all the 2400 minutes he had available. In the graphical solution, we see that the constraint is binding because it goes right through the optimal solution. Let us now look at the material equation. Here the cell value is 1400. Recall that the material equation was 10s plus 20l, which now, with our final value, reads equals 10 times 100 plus 20 times 20 equals 1400, which is exactly our cell value. Now the constraint is not binding because our cell value for the constraint 1400 is less than the total ounces we have of material, which is 1600. So our slack is 1600 minus 1400, or 200. In the graphical solution, we again can see that the constraint is not binding because the constraint does not go through the optimal solution. There is some slack. However, it is more difficult to see on the graphical solution how much that slack is. In the answer report, we can immediately see that the slack is 200. Finally, let us look at the storage equation. Our cell value is 260. Our storage constraint read 2s plus 3l, which now is equal to 2 times 100 plus 3 times 20 equals 260, which is, of course, binding because the right-hand side was also 260, so it has a slack of 0. Once more, in the graphical solution, we see that the constraint is binding because the constraint goes right through the optimal solution. To learn how to interpret the sensitivity report, please stay tuned for Linear Programming Basics 4.